So today we're going to talk about polygons. We're going to talk about some properties on them, different types. But first we're going to start with the basic definition. So a polygon is a closed figure in a plane. It's formed by connecting segments endpoint to endpoint with each segment intersecting exactly two others. All right, so on the right there we have some examples of polygons. Okay, now let me show you some non-examples. So for instance, if I had something that looked like, maybe even like, it started to look like a polygon, but like this, where the ends don't match up, like the endpoints don't match up. A circle, okay, that would not be considered a polygon because it doesn't have segments that are endpoint to endpoint. But those are non-examples. So one term that we need to know in terms of polygons is a diagonal. Okay, so this term diagonal right here, it's a segment that connects non-consecutive vertices. Okay, and we're used to diagonals actually with rectangles and squares. Like you've been told like fold on the diagonal or draw on the diagonal. And so a quadrilateral here actually has two diagonals. Okay, but if we look over here at the pentagon actually has 5 diagonals. So what happens is you start, so I can start like at one vertex here, and I can draw in my diagonals. So there's 2 diagonals just coming from that vertex, because those are the non-adjacent ones. So now when I move over to, say, this vertex, okay, so I have another diagonal here and here, and then I can go to another vertex, and then here's another diagonal. So there are 5 diagonals in a pentagon. When you get down to a hexagon, you can see down here, there are actually 9 diagonals, okay? And you can imagine it gets pretty big pretty quickly there. So at the top here, convex and concave are 2 different types of polygons. Okay, concave polygons have diagonals that actually go outside of the polygon. So on the right side there, you can see I've drawn in a diagonal. There's more, but I've drawn in diagonals that actually travel outside the figure. That is what makes it concave. Convex polygons are the ones we usually see, and actually we assume that polygons are convex unless it says otherwise. Think about, you've learned about convex and concave in science as well, but honestly, if you can take the shape and turn it so you could stand underneath the shape and stay dry, like a cave, like right here, that could be my little cave, it's concave. All right, so it's really important just from the standpoint of understand that we always work with convex. All right, then we have some common polygon names here. So we have the list of number of sides. Most of those you're probably going to know. Some that are not as familiar to people usually are 7 is a heptagon. Okay, 9 is a nonagon. 11 is undecagon, and 12 is dodecagon. Okay, those are probably ones that you're not familiar with. But then we have down at the bottom something called an n-gon. Okay, so after 12, we don't usually call it by its name. They start referring it to as like a 15-gon. Okay, or if it has 32 sides, it'd be a 32-gon. All right, so that's what the n-gon means. You just insert the number of sides. So we're going to take a second here. We're going to do a little bit of drawing, and we're going to do drawing later on. At the end of these notes, I'm going to do some drawings with you too. But we want to draw a hexagon, ESKIMO, where ES is congruent to IM and EM is congruent to SI. All right, so anytime you do these types of problems, you start, I read all the way through, but then I start, and as soon as I can draw something, I draw it. All right, so let's start. It says draw a hexagon. I know what a hexagon looks like. Okay, so a hexagon has 6 sides. All right, so I'm going to go ahead and draw a 6-sided figure. All right, so draw a hexagon, got that. Eskimo, okay? So the way you name a figure is you can start wherever you want, but then you need to travel in a circle around your figure. It does not matter if you go clockwise or counterclockwise, but what you are not allowed to do is you can't like skip around. You can't zigzag. It has to go in a continuously smooth circle. So I went clockwise. We could have also gone counterclockwise. Now it says ES is congruent to IM. So ES congruent to IM. I'm going to put my tick marks there. And EM is congruent to SI. Now EM is not drawn in. I don't have a segment EM, So I'm going to draw that in, EM and SI, and they are different lengths than my first set of congruent sides, so I'm going to put 2 tick marks here. All right, so we've talked about congruent sides and congruent angles. We can also have congruent polygons. Okay, that means that all of the corresponding sides and angles are congruent. So corresponding means like in the same position. All right, so up top here I have what's called a congruency statement. So I said CAMP is congruent to SITE. All right, so that means those letters are super important, not just because it spells campsite, but because the C is the first letter listed. That means that angle has to be congruent to the first letter listed on the other figure. So C and S, those angles have to be congruent. A and I, those letters have to be congruent. M, are not letters, angles, I'm sorry. M and T are going to be congruent. P and E, those angles are going to be congruent. And you can see from our figure down here that it's true. Okay, then you can also do that with segments. So CA, that segment CA has to be congruent to segment SI. Okay, AM, segment AM has to be congruent to IT, and so on. Okay, and I listed that down below here. Okay, so I listed that all down below so you can see that. But that order is super important because I can really cover up all of this. I can ignore this whole part here, and I can tell you that I have a quadrilateral. I have 2 quadrilaterals that are congruent. I can tell you which angles are congruent, and I can tell you which sides are congruent. All right, so let's take a look at this one. So we're going to fill in the congruency statements here. We have HOMT is congruent to ACES. Okay, so H matches up with, angle H matches up with angle A because they're both the first letter. Okay, then what angle matches up with C? Well, C is the second letter, so I need to match it up with the second letter. So that'd be angle O. What matches up with E is M. And then what matches up with T is S. So the fourth letter and the fourth letter. Then I can start comparing sides. So AC would be the first 2 letters here. So that would have to match up with the first 2 letters here, or points here. So this would be segment HO. All right, then what matches up with CE? CE is OM. What matches up with MT, our last 2 letters, would be ES. And then what matches up with HT, that's the first and the last, would be the first and the last on the right, which would be A and S. Okay, so a couple of things in terms of figures that we can assume and that we can't assume. So when we're looking at a diagram, a figure, okay, we can assume that angles are vertical angles. So if you see 2 lines intersecting, we can assume that the non-consecutive angles are vertical angles. Okay, if we're looking at a figure, we can assume the angles are adjacent. So it's not a trick, like there's not 2 rays that are really, really, really close together. We can also assume linear pairs. So it looks like a line with a ray coming out of it. You can assume those are linear pairs. Okay, what we cannot assume, unless there are markings, we can't assume that angles or segments are congruent. We cannot assume that an angle is a right angle. And we cannot assume that lines are parallel or perpendicular. Okay, again, unless they are marked. All right, what I want to do, oh, I'm sorry, a couple other vocabulary words here. So some of these words you've probably heard of in terms of triangles, but this actually applies to all polygons. So an equilateral polygon, lateral means side, okay, means that all sides are the same length. An equiangular polygon means it has a polygon with all congruent angles. If you put those together, if it's both equilateral and equiangular, it's called a regular polygon. Okay, a regular polygon has both equilateral, so congruent sides, and congruent angles. Honestly, they're usually like the really pretty ones. People, like when you're learning your shapes, it's the pretty ones that they put out there. Your square, your pentagon that's perfect, like the Pentagon building, the hexagon like that's down here below. Okay, so I'm going to take a minute here and I'm going to do a couple drawings with you. Again, just to practice that skill because it's not something that people are automatically good at. So we're going to draw a figure CAT with CA congruent to AT. All right, so I'm going to start at the beginning. Draw figure CAT. It has 3 points, vertices, so that means I need 3 sides, so it's a triangle. Okay, CAT, gonna go in a circle. Okay, with CA congruent to AT. So those are just congruent sides that I need to mark. All right, so I started you out pretty easy there. All right, here's our next one. Draw a polygon HOUSE with diagonal OE congruent to diagonal OS. All right, so draw a polygon HOUSE. So I'm going to start with 5 sides. Okay, and again, name them in a circle. So H, O, U, S, and E. Then it says diagonal OE, so I don't have OE. I got to draw it in. It's congruent to OS. Okay, to show that they're congruent, I need to put my little tick marks on there. All right, last example. Draw quadrilateral FROG with FR being perpendicular to RO. All right, so I'm going to start with, it says draw quadrilateral FROG. All right, so here's FROG with, so I got to label it FROG with FR being perpendicular to RO, meaning we have a right angle. So this is how I show my right angle. Okay, and I threw that in there because we talked about this a little while back, but that's the symbol for perpendicular, meaning they make a right angle. Okay, if I put in here the extra stipulation that, let's say FR is parallel to GO, okay, that means, remember we use arrows to show parallel? Okay, that would be that additional piece right there. So for your homework tonight, you actually have, I believe, 4 or 5 sketches that you're going to do. You can either use your tools within Google Slides to draw it, or you're welcome to sketch it out on paper, take a picture, and insert your drawing into those individual slides.